Somewhere in the world right now, someone is eating a pepper that is making their body panic. Their mouth feels like it is on fire. Their eyes are watering. Their nose is running. Their face is turning red. Every signal from their body seems to say the same thing. Stop! And then they take another bite. They order it again next week. They compete over who can handle more. They search for hotter sauces, stronger curries, sharper salsas, and peppers so intense that restaurants sometimes make customers sign waivers before trying them. Why? Why do humans love spicy food? Because from the pepper's point of view, this was never supposed to happen. A chili pepper did not evolve capsaicin to make tacos more interesting. It did not create heat so humans could make challenge videos. Capsaicin is part of a plant defense system. It is supposed to discourage mammals from eating the fruit. And for most mammals, it works. A squirrel bites a hot pepper and learns a lesson. A dog may sniff it, taste it, and recoil. Most mammals react as though the pepper has done exactly what it was designed to do. Humans are different. We feel the warning, we understand the warning, and somehow we turn it into flavor. The first strange thing about spicy food is that it is not actually hot. A chili pepper can feel hotter than a stove burner, but there is no fire in your mouth. The pepper is not literally raising the temperature of your tongue. It is not cooking your mouth the way boiling soup could. Instead, it is tricking your nervous system. Inside the nerve endings of your mouth is a receptor called TRPV1. Its job is to detect potentially dangerous heat. When something is hot enough to threaten tissue, TRPV1 helps trigger the sensation we call burning pain. Touch a hot pan, and this system helps you pull away. Drink something that is dangerously hot, and it warns you before you swallow too much. Capsaicin hijacks that system. It binds to TRPV1 and activates the same alarm pathway. Your brain receives a message that sounds a lot like, "Your mouth is burning." But your mouth is not actually on fire. That is why spicy food feels so strange. It creates a real sensation of burning without the ordinary source of heat. The person who helped uncover this mechanism was David Julius. His research revealed how capsaicin interacts with heat-sensitive receptors, and in 2021 he shared the Nobel Prize in Physiology or Medicine for discoveries about temperature and touch receptors. A chili pepper is not simply spicy. It is a tiny biochemical prank aimed directly at your pain system. So why would a plant want to do that? Because not every animal is the same kind of eater. A chili plant needs its seeds to travel. If a fruit falls directly beneath the parent plant, the seeds may compete with the parent and with each other. But if an animal carries the seeds away, the plant gains a chance to spread into new territory. Birds are excellent seed carriers. They fly. They move long distances. They often swallow small seeds rather than grinding them with broad, chewing teeth. The seeds can pass through the bird and land somewhere far from the original plant. Mammals are less useful from the pepper's point of view. Many mammals chew fruit thoroughly. They can crush or damage seeds. Rodents may eat seeds without moving them far at all. A pepper plant needs a way to discourage the animals that destroy its seeds while allowing the animals that spread them to keep eating. Capsaicin helps solve that problem. Birds are much less sensitive to capsaicin than mammals. They still have sensory systems, of course, but their version of the relevant receptor responds differently. A bird can eat a pepper that would make a mammal recoil. That is why you may see birds eating bright red chilies with no visible sign of discomfort while a squirrel avoids the same fruit. To the bird, the pepper is food. To the mammal, it is a warning. And then there is us. Humans are mammals. We have the full warning system. Capsaicin activates our TRPV1 receptors, just as it does in other mammals. We cough, sweat, cry, and reach for water. But unlike most mammals, we can learn to enjoy the alarm. Nobody is born loving chili peppers. Small children usually react to spicy food the way you would expect. They pull away. They grimace. They refuse another bite. Their bodies treat capsaicin as a threat. That does not mean they are weak. It means their nervous systems are working. Liking spicy food is usually learned. Psychologist Paul Rosen spent decades studying food preferences, including the way children acquire a taste for chili. In communities where spicy food is part of daily life, children do not instantly love it either. They are often introduced gradually. A tiny amount of chili is mixed into familiar food, then a little more after that. Over time, the burning becomes less shocking. The child learns that the sensation is temporary. The food is safe. The people around them enjoy it. The flavor becomes linked with family meals, comfort, celebration, and belonging. Eventually, what once felt painful can become desirable. That is a remarkable thing. Your body says, danger. Your experience says, this is dinner. And your brain learns which message to trust. This may be one example of what Rosen called benign masochism. It sounds dramatic, but the idea is simple. Humans sometimes enjoy experiences that trigger negative bodily signals when we know the danger is not real. A roller coaster creates fear. A horror movie creates dread. A very cold swim creates shock. A spicy pepper creates burning. Your body reacts as if something bad might be happening. But another part of your mind understands that you are safe. And inside that gap, many people find excitement. The burn becomes a challenge. The challenge becomes a rush. The rush becomes something people seek out again. That does not mean spicy food is enjoyable for everyone. Some people dislike it forever. Some people have medical conditions that make spicy foods especially uncomfortable. And extreme pepper challenges can cause real symptoms, including severe pain, vomiting, and digestive distress. Spice should not be treated like a test of courage. There is no prize for hurting yourself. But for people who enjoy it, the sensation can become part of the pleasure. It is not only pain. It is pain mixed with flavor, aroma, anticipation, culture, memory, and relief. The relief matters too. After the burning peaks, your body begins to calm down. The rush fades. You reach for food, a drink, or something creamy. The discomfort becomes manageable. Then, it becomes a story. I survived that. I could handle more. That sauce was incredible. And this is where an ancient plant defense becomes a human obsession. But spicy food is not only about thrill-seeking. It is also about culture. Chili peppers are native to the Americas. For thousands of years, indigenous peoples in the Americas cultivated and used them as food, seasoning, medicine, and more. Long before chili peppers reached Europe, Africa, India, or Asia, they were already deeply woven into cuisines across parts of the Americas. Then came the Columbian Exchange. After Europeans arrived in the Americas, chili peppers traveled across oceans with traders, colonizers, migrants, farmers, and cooks. Their spread was astonishingly fast. Within a few centuries, chilies had become central to cuisines far from their original home. Today, it can feel impossible to imagine many dishes without them. Indian curries, Thai soups, Sichuan cuisine, Korean kimchi, North African sauces, West African stews, Hungarian paprika, Italian peperoncino. But chili peppers are not ancient to all of those places. They arrived. People adopted them. Then people transformed them into something local. That is one of the most beautiful things about food culture. A plant can travel across the world and become inseparable from a place it did not originally grow. A pepper from the Americas can become part of a family recipe in India. A spice traded across oceans can become the taste of home in Thailand. A sauce can become so familiar that people forget it once arrived as something new. And why did chilies spread so successfully? Partly because they are productive plants. Partly because they are colorful, flavorful, and easy to dry. Partly because they can be used fresh, smoked, fermented, powdered, pickled, or cooked. And perhaps partly because spice does more than make food hotter. There's a famous idea that spices became especially important in warm climates because some spices have antimicrobial properties. In 1998, researchers Jennifer Billing and Paul Sherman examined traditional recipes from different regions and found that hotter climates tended to use more spices. They proposed that spices may have helped slow the growth of some foodborne microbes before refrigeration. It is an appealing idea. Meat spoils faster in heat. Food preservation matters more when storage is difficult. And many spices do contain compounds that can affect microbes in laboratory settings. But scientists still debate how much that explains real-world cuisines. Flavor matters, local agriculture matters, trade matters, religion matters, history matters. Once a food tradition becomes part of a culture, it does not need one single practical reason to survive. It can endure because people love the taste, because recipes are passed down, because it reminds them of family, or because it simply feels right. Spicy food may have been useful in some situations, but no one should imagine that every hot dish was invented as an ancient medicine cabinet. People also eat chili because it tastes good to them. And that is the final twist. Capsaicin is a warning signal designed by a plant to discourage mammals. Humans did not erase that warning. We still feel it. We still sweat. We still cough. We still cry when the pepper is hot enough. We simply change the meaning. A squirrel tastes danger and leaves. A bird barely notices. A human tastes danger, adds salt and lime, and asks for seconds. We took a plant defense and turned it into a ritual. We taught our children how much to use. We created sauces, powders, pastes, pickles, oils, and dishes built around the burn. We crossed oceans with it. We made it comfort food. So why do humans love spicy food? Because our bodies can feel the fire, but our brains can learn that the fire is safe. Because culture can turn pain into flavor. Because a warning can become a challenge. And because once a chili pepper became part of a meal, it stopped being just a defense mechanism. It became a story humans wanted to taste again. What is the hottest food you genuinely enjoy eating? Leave your answer in the comments and subscribe to Andy for more strange science hidden inside everyday life.